Good morning, everybody, and welcome again to the second day of EASA high-level conference on drones. So this second day is more on technical workshops, so it will be a little bit more technical, so I hope you are fit for now a deep dive on standardized European rules of the air, ATM procedures, and operational aspects. So I would like also to welcome the people online. So we are also having some participants online. And therefore, we will have a mixture of how we manage the questions. So we have some questions that the online colleagues can put on a Slido. You can see that on the main screen with the hashtag, actually, 026497. And for the participants in the room, and since we are relatively short and cozy, so I would say, there's no huge meeting room, so we can perhaps address so with a microphone. I hope the technicians have a spare microphone, and so microphone for their questions are available? Yes, perfect, thank you. So I hope you are enjoying the high-level conference on drones. And yeah, so without delay, I'm going to start by introducing our very excellent experts and distinguished panelists. So I will start with Olivier MROWICKI from EUROCONTROL. He is the program manager for aerospace management, traffic services, and traffic flow and capacity management procedures. He is, I will say, one of the dinosaurs in ATM. Very knowledgeable person. Also, he holds a PPL. So, and he is the father of standardized European rules of the air. He actually was the project manager for that in EUROCONTROL. And he started working on the transposition of ICAO Annex 2, Annex 11, and PANS ATM back in 2007, when you received the 2007, 2000. Well, we were there.
Yeah, sometime.
Sometime, yes. Then I will go to Jörn JAEGER. He is also another dinosaur in ATM, I will say. He is now in VOLOCOPTER as a head of Airspace and Vertiports. But his background has been always on ATM and working for DFS, so a great expert. So I go now to my right-hand side. So we have the Commission. Nicolas, so policy officer for UIS, but also a very good expert and great expert on ATM, since he is seconded from EUROCONTROL, and huge expertise on surveillance. So we have NORTMANN for UAV-DACH and director of UAV-DACH service, but huge expertise because he holds, I think you hold a CPL on helicopter.
Not helicopter, but all airplanes.
All airplanes. So here we go. And huge expertise as an aerospace user, and also using those rules of the air and those ATM services since a long time, and now helping us on how to apply those to UISs. And the last but not the least, my dear colleague, Thomas OSTER from EASA, as a project manager for UIS, but with a huge expertise on ATM and CNS. So he's a real CNS expert, military-civil cooperation, so he's helping us. He's seconded from EUROCONTROL, and he's helping us with all these topics, and he was the project manager for what I'm going to present to you. So this workshop, integration of VTOLs in the aerospace, and the developments of ATM SERA. So we started this work back in 2019, when we started the work of extending the regulations for UIS in the certified category. And we came with the conclusion at the beginning that we need to address this by dividing the huge amount of use cases of UAS in the certified category into a little bit smaller package. So we decided that based on what we knew from industry, so in EASA, what we knew from industry out there, the first use cases that we could start working on was the big ARPAs, remotely piloted aircraft, who are able to fly IFR, therefore they are equipped, certified as an IFR, and they are able to follow IFR procedures and rules. That was our Ops Type 1, and you will see that in the MPA, which will go out in 3 weeks' time for consultation. That was Ops Type 1. Then we have Ops Type 2, which is UAS, which are VTOLs also, but without the pilot on board, and that they will fly mainly in a US-based aerospace. These ones now are being postponed a little bit, because what we see that the industry tell us that they would like to start first with Ops Type 3, which is the pilot is on board the aircraft, is a manned VTOL, will follow VFR, but there are some challenges that the panel will address. So we created a subgroup of an expert group, huge expert group with a lot of experts helping us on developing those rules that was mainly concentrated on ATM and SERA, so the standardized European rules of theirs. Our European rules, which transpose Annex 2, certain procedures and requirements of Annex 11 and PANS ATM. And the colleagues here, they are a subset of that working group, which Thomas will talk a little bit also about, because he was the project manager. And so that is the introduction for the purpose of this panel. And I will start with Olivier. So Olivier, so you are the father of SERA.
So you can blame me.
Yes, we can all blame you. And
Father, dinosaur.
Stay here.
yes.
Oh, I go there.
Yeah, no, we stay here. So we just sit to be with you. Sorry, we just sit. So let's see if my tablet is cooperative. Because so Olivier, you, the father of SERA.
Yes, and I don't know if the slides would come up. I need to press. Oh, it's perfect. So, yes, SERA, the rules of the air for Europe. And in general, we hear a lot of things about what are the regulations. The regulations need to be changed. They need to be adapted for new entrants. We hear about unmanned flying rules. We hear about electronic flying rules and whatnot. And that's very good. That's very nice for the future. That might happen in a fully connected environment in 10, 20, 30 years. But what are we going to do tomorrow? And that's the approach that we decided to follow. And looking at the rules of the air, you see on the slide, what do we have there? We have the component, the objectives, the root objectives of the rules of the air. What are they made for? They are made to ensure proper navigation, vertically and horizontally, and that's why VFR and IFR were created, depending on the technique of navigation. They are obviously also aimed at safety, and the primary objective is to avoid collisions in flight. Of course, if there is only one aircraft in the air, it's fine, but as soon as there are two, there is a risk of collision, not to mention when the density of traffic increases. Planning and regularity became also something very essential in the rules of the air, and that was introduced with flight planning, air traffic services. The regularity of which is also important for the continuity of the services to be provided, for example, with the surveillance service provided by ATS, opposed to what it was at the very beginning, only on a request of pilots. Communication is essential, and the requirements for two-way communication are in the rules of the air as well, the reporting requirements as well, and of course the phraseology, because the coded language that is used between pilot and controllers proved many times, unfortunately, that communication is not an easy exercise, and that, on the contrary, it's easy to misunderstand someone if not referring to standardized communication. And of course, I would not forget at the end the common awareness for safety. What does it mean? It means that using a common set of rules for all players that is understood and known by all players is essential. That's about procedures. Technology is nice, but procedures, how to use technology, is essential, and there is always a human being somewhere in the loop that needs to be trained. And all that together is aimed at safety. And it's important to mention, because you saw within this list, there is no priority of business. The only priority is to avoid collision. So safety is really the central word. So how did we decide to look how the new entrants could be accommodated? In fact, looking at the existing rule, we had to consider which are the requirements which are easily compatible. I'm talking about the requirements of the new entrants with the existing rules. And in that case, we tick the box, nothing else to do. But then we had also to identify which requirements of the new entrants would not be compatible, but would be with some adaptations, and which adaptations could be possible in a realistic time frame and realistic effort to integrate the new entrants within the existing aviation world. And finally, some requirements may not be compatible, and in such case, we need to find alternative solutions, how to accommodate them. And all of you know one of them, the easiest one, which is segregation as a starting point. So, like Maria introduced, the concept paper and the existing regulations, they envisage open specific certified categories, and each of them, they have specific requirements depending on their type of operations they envisage, and it's a very wide variety of type of operations that we have to consider. So among those new entrants requirements, we have some that are known and confirmed. They are fact. We know that they will continue. Some of them are expected. They are not validated or not yet on the market, and some of them are foreseeable but not sufficiently known today to be considered as facts ready to be addressed. So what we did in the work of the review is to take a pragmatic approach. First of all, to collect the relevant operational requirements, and it's not always easy because not all the players are available, and sometimes some elements are not mature or they are not commercially releasable, and it's not always easy to have several potentially competing companies around the table telling us all the details of how they want to operate. Then it was necessary to map and sort out the requirements, to review against the rules of the air with the criteria that I described just before, and to identify what actions could be initiated to achieve the goal of integration. So just a quick picture to show you the long list of sections in the rules of the air, where you see the main sections, but within each section you have requirements and paragraphs and acceptable means of compliance and the rest. And for each of them, we went through each paragraph, comparing to the various situations with U-Space, without U-Space, and U-Space was still under development at that time, with a pilot on board, without a pilot on board, with a remote pilot. So that was quite an extensive work that we conducted starting in 2018-19 to reach what Maria mentioned, the NPA that will be soon released. So as a summary, what we did to analyze and sort out the requirements of the new players, to confront the requirements with the rules, and to identify what were the possible options for accommodation or for deviation. And the answer being either to adapt and complement the rules, to identify the necessary additional capabilities that may be required from the new players if they want to integrate, and or maybe of the old players as well, and to identify the practical solution, as I said in the beginning, to be able to start tomorrow the operations and not to wait for the fully connected environment in 2050. And that's it, what I wanted to say as an introduction to the subject. And of course, I guess we will have interesting exchanges later on. Thank you.
It's very I would say, very detailed introduction to SERA objectives. So, and to how SERA was developed, what is the main objectives in terms of safety and in terms of a traffic service. And it just goes now very nicely, because I would like to address Thomas a question. So, Thomas, so now that Olivier has explained all this, could you go a little bit detail on how the assessment was done in your working group, so that we came up with the product that we are going to publish in 3 weeks' time? Can you explain us a little bit more?
I will do this with pleasure, but first I need to take the power
yes.
from the dinosaur.
The dinosaur.
Okay, I have prepared some slides to illustrate to you how we did go through this challenging task, where me being an engineer, as Maria said in the introduction, I was immediately sitting there having to lead a group of, we were close to 40 people. The colleagues you see here on stage were all in it. And I had to manage that task related to SERA, which was, of course, not too easy. And as Olivier already highlighted, the ATM SERA is mainly there. The main purpose is to allow safe and orderly and efficient air traffic in terms of manned aviation. And now we had to look at this and always keep that in mind for the introduction of the US traffic in the same airspace. And we all know SERA has one major objective, if not the major objective, to avoid collisions in the air. And this now would have to include the drones traffic. And we all know that the major principle that Uwe, when he's flying, or Olivier, when he's flying, is the see and avoid. You see the other traffic and you try to avoid it, yes? And we all know that a drone, a real drone, an unmanned drone, we cannot use the see and avoid principle, because the drone as such has no eyes. So we were facing this issue. And Maria was already referring to the EASA concept paper, which was talking about the types of operations. So I took the freedom here to quickly recap again what are the 3 types of operations. The type 3 operation is the manned VTOL. That's what we are going to establish with the first NPA step in order to make that available. And for us in our work, easy fact, which was easing our work a little bit, was that we still have a pilot on board flying an aircraft where he has full control about. He can apply the see and avoid principle because he sits in a cockpit, he's looking out of the windows, he can avoid traffic provided he sees it. And at the end, summarized in the little yellow box, you see there that yes, the conclusion was it's like manned aircraft, but almost like manned aircraft, because there are some changes. If you look at the details of SERA, you find the term fuel. Those animals, those new entrants, most of the times will not have fuel. They will have electric energy. So we were discussing how do we reflect this in the rule. And we said, okay, it's simple. We add fuel/energy, but not in all cases. For example, just to give you a detail, in the terminology, in the phraseology, we said, okay, we don't expect now the controller controlling probably such an aircraft to say fuel/energy. Yeah? So he will continue to say just low on fuel or whatever the pilot. And as well, the thing, they are almost like helicopters, so we were thinking about the definition of that. And in the future, you will see helicopter/manned VTOL capable aircraft. Next type of operation, as Maria said, it's the type 2 in urban environment inside use space. And the difficulty there is that SERA requires aircraft shall not be flown over congested areas, over assembly of person. You should maintain minimum heights, And to enable such operations, yes, you would need the technical system detect and avoid, which unfortunately today is not yet available in a fully certified and verified variant. So in the first step, please keep this in mind, the first step, which we are going to take soon, we cannot anticipate that we have DAA available. Okay, you may have heard about the Rule 666 in the U-Space regulatory package. It's about the U-Space outside controlled airspace, so in uncontrolled airspace. And there we say we require a conspicuity device for traffic to be seen, and the drones as well need to be visible in there. And initial operations, that's what we discovered already today, they will only be possible on predefined routes to really ensure safety. And if we go for step 2, which is then about enabling type 2 operations, we will have further challenges, and we will have to discuss in even more details and more difficult discussions, I'm sure, what to do to accommodate them. And then we will have to touch, just to highlight 2 issues. How do we deal with VFR rules in the SERA in relation to drones where there's no pilot on board? And how do we talk about and deal with a pilot in command? Last but not least, maybe the most simple one, but I may be completely wrong, is the Ops Type 2, IFR unmanned cargo in airspace class A and C in the first step. We anticipate, or we simply assume, those aircraft are fully IFR certified. They can fly with, in compliance with IFR rules. They are compliant with all ATM, SERA and CNS requirements, and they do have a detect and avoid capability. So despite its named Type 1 operations, this will be the last one to come. So we are talking about a time frame of 26, 27, even later, but this may change. And what we need to assess there is depending on other things. We need to wait for what is ICAO finally putting out in form of standards for this kind of operations. And as said before, we are pending on the availability of technical solutions. The DAA is the best example here. So, what did we do? As I said, I found myself being the leader of a working group of almost 40 people. In the first attempt, we did have a look together with all people around on the whole of SERA, and then we came to the conclusion, yes, of course, we cannot do the work, the detailed work with all these people, and we did split into expert groups. So even in this first attempt, we did go through all the 3 kinds of operations with little expert groups, where, for example, you were with the Ops Type 1 with us as well. And then we had one on Ops Type 2. And the one where you see the results in the upcoming NPA is the expert group related to Ops Type 3, which is the first step. What did we do in this group? This is a graph I thank to Jörn, our colleague there. He was providing this slide for the basis of our work. This is in fact where you see the manned VTOL capable aircraft operations in the 4 different possibilities of airspace constellations. It may fully fly in uncontrolled airspace. If it's in U-space, it may be a U-space inside controlled or outside controlled airspace. Or you may fly probably in controlled airspace only at a later stage. So we, for our work, had to take assumptions. And the assumptions which we took, you see the major ones here, we said the pilot who is in the cockpit will remain fully responsible. The pilot which is flying there, he will be fully rated. He will have a training exactly like a manned aircraft pilot, and the licenses required for that type of aircraft. And we anticipated that when such an aircraft is flying inside the U-space, it will be in controlled airspace, he will be managed by ATC. If that U-space is in uncontrolled airspace, that's a different game. And UAS flying in the EU space definitely will be managed by the USSP, not by the ANSP. We considered that for the initial phase, there will be only VMC daytime operations. And we said, since this is a manned aircraft, which will receive full service of the ANSP, for the time being, we will not anticipate that they have access to the U-space services, or they are not using them for the operational purpose. That was the major things, and here I wanted to show to Olivier that the SERA was even there before you invented it. Yeah, Toyota was having a type SERA car already in the 80s. So thank you.
Thank you very much, Thomas, for going even deeper in the discussion on what was the work of the expert group and what was the assessment down, and even you highlight some of the conclusions. And I think we will go further in the discussion. So thank you very much for now.
Welcome.
I would like now to give the floor to Jörn. So from VOLOCOPTER. So the future animal, like Thomas is saying, the future animal in the sky. So Jörn, so how do you see the work that we did, and in your view, you will be flying at the beginning BFR, BNC. How do you see this matching your operations? Can you explain us how you see operations inside control aerospace, outside control aerospace, within US space, outside US space, and how do you see your flights profile up, in and out a vertiport?
I'm happy to do so. Yeah. Thanks. So, first of all, I think it was a great collaboration, and I'm very grateful to have that the chance also to be a member of that working group, and specifically, as also Olivier said and Thomas, I think it was really necessary to tell or to speak about our intended operations, to not build some regulations or standards that are not really fitting the purpose of our operations. And that's why I think it was good to have that close alignment, and it was stressed already. We really talk about the initial operations. To make that very clear, we're not talking about something very highly automated or even autonomous. I think that became clear already. So with that, I would like just to introduce you a bit again, the idea how we intend to operate initially, and that we can start tomorrow. I would like to start with that picture here, showing you the implications, or as we see the urban air mobility from the volocopter perspective. So we clearly have to distinguish between the different use cases, and with that there comes the different airspace constellations, as we mentioned them already, and I will come to that in a minute more in detail. So we really have, as Volocopter, targeted the urban air mobility with the aircraft that is called the VoloCity. So we really want to fly in and out of the heart of the cities. We have aircraft and others as well. I'm not speaking here, I think, on behalf of Volocopter, but of all VTOL manufacturers and intended operators. Aircraft that fly beyond the city limits in rural areas, so more or less maybe also uncontrolled airspace. And we have unmanned aircrafts already, and I think for that also we have an aircraft here illustrated, what we call the Volodrone. Cargo, unmanned obviously, also for initial operations, and we have to see how these operations all fit into the SERA framework. Also that picture just to illustrate you a bit, and I think that gives a bit of an imagination what we really intend to do, because also talking with different people, making use of existing infrastructure at airfields, I think that is one of the use cases, but we really also target the inner city locations, and you could see where a vertiport, obviously that's the term for the takeoff and landing sites for our aircraft, could actually happen, and that puts some challenges with us, and that relates not only to the ground but specifically to the air and the surrounding airspace, and the vertiports, as you just mentioned, Maria, of course, have to be connected to that. So that's why we see a really strong connection between also the vertiport design, operations, connection to the airspace, and the services that are provided. The stakeholders that are involved, are that still the same stakeholders as ATC, the one providing services at the vertiport? So questions like these obviously arise rather quickly. And I just brought the same illustration here with me, and the former version you saw already from presented by Thomas. So really to make sure and clear that we have to distinguish these 4 cases. So whenever we start talking about it, I would then, if somebody tells me we have to do this and this, I would always like, okay, what picture do you have in mind? Where do you see us flying, or explaining where we want to fly, and then it becomes much more clear what is really relevant and what is irrelevant. And that is, I think, something we clearly need to distinguish. And as we talk with authorities, and I'm also very happy to have now the NPA shortly available, that we can really build on that with cities, and I see some representatives here in the room, which I'm very happy, that we really can base our discussion on these cases and see how the competent authorities in these cities and these countries are able also to apply SERA, and what the flexibility that is built in SERA. And I think that is something I also learned in the discussions that we had. There is actually quite a lot of flexibilities in these regulations. I can only make the plea here really to use the flexibility that is built in. We don't need to change everything, as specifically Olivier mentioned before, but I think if you apply them in a different way, not always think in solutions that work for helicopters, for example, but have a bit of modifications, I think there's quite a lot of possibility built in. And with that, also you see it here on the right-hand side, what is our intended operation. It was mentioned, it's manned. So clearly there's a pilot on board, the pilot in command. It's very much like VFR operations in the beginning. We are in different airspace classes, mainly specifically flying in and out of airports, but also closer to airports, that's controlled airspace. But we see actually also airspace in city centers not necessarily has to be controlled airspace. So we actually have an uncontrolled airspace, so where there's no ANSP responsible, there are basic services, you all know that. How do we deal with that? Is there any other opportunity? And we will come to that, I think, with use-based and use-based service providers, to what extent we can already make use of these services. Is that acceptable? What is the responsibility, of course, that comes with it, with the pilot, with the air operator, but also with other parties involved. Also, to make it very clear, we can take off and land at existing airfields. That could be conventional airports, heliports, but also new infrastructure that we call the vertiports. All that is possible. So I think there are plenty of opportunities, and we see that again, talking now to our partners already in the cities. So I think making use of existing infrastructure is also a good initial step to start operating and showing how it could work. And also making very clear, we are flying here in very low level airspace, which we usually consider between 400, 1,000 feet. We know, we come to that in a minute, I guess, also minimum flight heights, congested areas, that does not really fit here. But still, we know there is the exemption for takeoff and landing, and also in discussions and, of course, in agreement with competent authorities, there are already the chance to fly below that. Challenges still remain, obviously. So yes, we have to discuss what are the minimum flight heights. We also know, and we experienced this already, as you know, VOLOCOPTER has done quite a couple of flights, also in public, be it in Helsinki, specifically also in Singapore, in the heart of the city. There are challenges when it comes to coverage of communication, means of conspicuity. So I think this is something we need to have a closer look into. Obviously, with the number of VTOL aircraft increasing, I mean, the workload for air traffic controllers is increasing as well. So I think that's not the intention, really, to put another workload on ATC. We could still argue, is it really meaningful at all to have ATC involved in that operation, as we talk a very regular operation, have to more the picture like a cable car operation. So really very clear routes, predefined routes, pre-surveyed takeoff and landing sites. We will not take off of a cross junction and not in the backyards of anybody who wants just to call the air taxi in the beginning. So that is very clear in the beginning. There could be letters of agreement with ATC, and with that I think we can make clear that we have a very regular operations. And with that I think interaction with ATC should rather be the exemption than the rule, but of course we have to go there step by step. Also, we need to tell everybody, and I think it is obvious once you know it, that electrification of aircraft is still a bit a challenge when it comes to endurance, also resource management of energy. So also we have to explain to our partners that the flight trajectories should be designed according to the aircraft performance, which allows, on the one hand, other takeoff and landing profiles. So we are not bound to the profiles and procedures as for helicopters. But at the same time, I mean, it doesn't make really a lot of sense to fly any detours, have holding patterns and things like that, which are common in normal aviation, but actually for our aircraft operations, and that is true, I think, for any electric aircraft, we would like to have a very short and, the shortest flight possible. And that is also, we have to tell the partners, you know, that we cannot accept, or, you know, it's hard to accept that we have any uncertainty when we take off. So we have to be sure, okay, when we take off, there's already, the airspace is free. There's a slot, if we call it slot still, at the destination vertiport. And with that, I think we have to understand the needs and the performance and the chances that we actually have the different animal, as it was what called today. And yes, of course, we have to make sure, I think that's in all our interest. I think nobody would argue about it, to have the safety, and that means separation with manned and unmanned aircraft that are around us. And with that, yes, that was a short introduction about the initial operation that we planned, and I think we may come to that even in the discussion. I'm happy to take more questions on that, how we want to integrate. And obviously it was mentioned as well, initial operations, manned aircraft, and we know the U-Space regulation is not really using U-Space in the beginning, but I think this is something we are aiming at, and I think we'll come to that also in a discussion, what U-Space may offer and as opportunities for our operations. So with that, I hand over back to you, Maria.
Thank you very much, Jörn, for the explanations of how you plan your initial operations. So I'm happy to see that we are aligned on the initial set of operations, and of course a lot of discussions will be on how to manage those aircraft, those traffic when the traffic will increase. So we'll come back to that. I would like now to ask Uwe, you are today representing UAS community, so a manned aircraft system, but you yourself are utilizing the aerospace as an aerospace uses, but I would like to tackle the question from an unmanned aerospace uses perspective. So how do you see the manned VTOLs flying in the aerospace together with a manned aircraft, and how do you see the use of electronic conspicuity for the traffic avoidance, for the collision avoidance, and how do you see the SERA application to those?
Yeah, thank you, Maria. Welcome to everybody. I would like to take the view not with slides, but direct on your questions. From my perspective as a professional pilot and member of the UAV-DACH Association. I was combining both within EADS Cassidian as a head of unmanned systems operation in Friedrichshafen, and there we had a very simple approach. It was, we have full conspicuity of the UAS, and we have a segregated airspace, and there is no problem to combine the traffic. But as a member of UAV-DACH, our first goal is full integration into the airspace for both UAS and manned aircraft, and that requires, of course, the full conspicuity of both with the same standards. As we heard by Olivier already, this will take a long time, and so the task was, of course, how to make it now safe again, but without the conspicuity. See and avoid principle can only be made by visible VFR traffic, looking with pilot eyes, and or by conspicuity. My first question was, why do we separate in type 1, type 2, type 3 operation? I don't like this. I would like a rule which says every aircraft coming into the air has to be full conspicuity, and please make the standards as quick as possible and make such a rule as a requirement, as a general requirement. Then we don't discuss about new rules. But it is impossible, as we learned, and it is still not impossible. It's not possible now because the standardization takes time, and we don't have a solution on the table since 2018. Nothing is going really forward, and therefore we decided in the working group, of course, together with EASA, okay, let's segregate in such a way that we make that different type of operations. It's the only way to make safety. And so I'm glad as a professional pilot, of course, that we take this way. And I like the Type 3 environment, of course, which is saying there is a pilot on board. He is full license, full qualified, and special rated, of course, on his type of aircraft, the VTOL. And he shall have the full responsibility. So he has to get all the information required by the system, by voice communication with the special SERA regulation of communication means, of course, and by the information of USSP or ATC. And with all this information, such a pilot is enabled to take the decisions, and then he can have the full responsibility of the flight. So that's a way forward to make traffic safe. And for the so-called air taxis, as I still keep this wording for the VTOLs, I think that's a good approach, and we should follow very soon, and I appreciate the NPA coming on that. And yeah, based on that, the other types of traffic, type 1, you heard already, is rather simple. There's no pilot on board, but we have the full conspicuity of the aircraft, the full certification of such IFR traffic, and there's no change in principle for SERA. So we only had to make some changes, as Thomas also explained, to adapt the wording with fuel, or to adapt see and avoid with a conspicuity requirement and so on. So my answer is that, well, segregation in this way is a way to go forward, and I welcome the approach of EASA, but I still have in mind we should very soon come to the full solution with every aircraft being full visible to each other. Then we don't need a new regulation, because SERA is made very well and it's operating quite good.
Thank you very much, Uwe. I could not agree with you more. The end goal is integration. Now, how we arrive there is going to be a little bit. It's going to be Nicolas who is going to tell us. Nicolas from the Commission. So you are working on the Commission on the drones strategy 2.0. So I guess you have all heard about this is a very important work for all of us. Colleagues, you really need to look at the report and give your feedbacks, because the Commission will set the strategic objectives for drones and our work until 2030. So you have seen what we are doing today, what the group come up in order to accommodate MAN VTOL, VFR, they only VNC. Operations, but you have heard already from the Airspace that that won't be the end goal. So have you addressed this in the drones strategy work? What could be the next steps? Because our time frame now is 2024 with this MPA. But we need to look further. So what are the main building blocks you have in the work? And if you could give us already, maybe, I guess you cannot give us everything, but a little bit on where the lines will be going.
Yes. So, well, first of all, we don't have all the answers for the integration of all traffic yet. But, of course, by aiming at 2033, 2030, sorry, we are a bit more ambitious than what we are looking at here. I mean, when I say we are a bit more ambitious, I do not want to diminish the effort that has been done. I think Patrick Key said it very clearly yesterday. We have achieved together, we have met a number of milestones over the last few years, and we have achieved in 3-4 years more than what has been achieved historically in aviation regulation. So what we have delivered in terms of regulatory framework is quite amazing. We have enabled operations in the open and specific categories. We have defined rules for the design and manufacture of small drone. We are progressing quite rapidly on the regulatory framework for the certified category. But indeed, we are still working in a logic of largely segregation to ensure the safety of the operations. We are accommodating the new entrants. We have developed a use-based regulatory framework to allow the operations of drones and manned aircraft. with traffic management, with improved overall situational awareness, with an interface to the ATC, but it largely remains two separated worlds. So as Type 3 and Type 2 operations will develop, we will be faced with an increased traffic of drones in urban environments that may be controlled by or supported by use-based services, and an increase of demand for Type 3 operations where we will have piloted EVTOL aircraft, potentially transiting through use-based airspace, but likely with the support of air traffic control services. Today, most major cities are in a CTR of a nearby airport, so it is controlled airspace. Of course, we could expect or we could hope that there would be some airspace reorganization to allow for those operations, but still we are going to work largely with a segregated system. So we have to look a bit further. So by 2030, we will probably not have reached a full integration of both worlds, but we have to reflect at how to actually improve that integration. So how can we really start mixing both traffics in a more seamless manner? I think that one objective could be to start providing use-based services to manned aircraft. Today, we really have two completely separate worlds where ATC is in charge of manned aircraft, use-based may provide services to unmanned aircraft, but according to the current regulatory requirement, regulatory framework, use-based service providers cannot provide use-based services directly to manned aircraft. I think this may need to be addressed in a future evolution of the use-based regulatory framework. And then we may need to start looking at maybe not unmanned flight rules, but I think it's more automated flight rules. Automation is not just happening in the unmanned world. Automation is already largely present in manned aviation, but some operators are clearly looking at going single pilot and eventually removing the pilot from the cockpit and relying largely on automation with potentially people on the ground, of course, overseeing the operations. But automation is also increasing in the ATC, and it's an area where it has taken time, so it will probably take a long time to fully automate, but where the controller is also likely going to transition from a controlling role to an oversight role, and this will also potentially have an effect on flight rules. So I think Drone Strategy 2.0, we are looking at Horizon 2030. So not full integration by then, but we are really hoping that we can start integrate traffic a bit better than today. And I think providing use-based services to manned aircraft is probably a first step. I don't think we will have fully new automated flight rules by then, but we should probably start working on them. Thank you.
Thank you very much, Nicolas. So you have said two interesting topics that I guess we can discuss in length. So one is the provision of US-based services to manned VTOL and how this could take place. And the automated flight rules is indeed something that has been put forward by many initiatives, and it is true that it's quite a difficult subject to tackle on how we go there. So how we can have a set of rules which can be automated and which can means maybe different things for a manned traffic than for an unmanned traffic, but at the end achieve the same set objectives. And with SERA, I go back always when I have SERA in mind, I go back to Olivier. So Olivier, you have now here all the colleagues and also the Commission. So where we are heading, where the plans for the drones strategy. what will be what the main challenge do you see in addressing, for instance, Ops Type 2 and high level of automations of Ops Type 3? So what Nicolas was saying, removing the pilot from the aircraft, increasing the level of automation on the cockpit, increasing the level of automation of traffic controllers systems, the ATM. What are the main challenges do you see there?
Thank you for the question, Maria. We have only an hour or so to list all the challenges, but to make it simple, the first challenge I would see is about altimetry and having a common altitude reference system that is working. I believe it's really something that is essential. Having the different measurement systems is not the only issue, but having the same zero reference in a certain given airspace is definitely something that is essential for integration. And as I underlined in the objectives of the rules of the air, the capability to avoid collisions in flight is essential, central, and probably the most important challenge. The question is how to reach a satisfactory collision avoidance in flight. The common altitude reference system is an element of it, and the detect and avoid capability is another element of it. With a ground segment, without a ground segment. In fact, we have to take into account the complexity and the fact that the rules, they were made on an empirical approach with a little level of traffic in the beginning that has been growing over time with additional tools, additional rules coming. And we are now in a situation where we cannot consider the new operations in isolation, because when the operations of Jörn that were well described before start, it will not be with one aircraft in one place. It will be with a regular flow of aircraft, and that dimension we have to take into account. So the traffic density is also something that is important, how this should be organized, because we cannot expect that in a complex urban environment where most likely some areas will not be possible to overfly, that the things could be left to chance how to organize the flight paths and trajectories. All this will have to be organized from the very beginning, and of course that is adding to the complexity. Another element that might be less obvious, you know that the rules of the air, they are often also observed from a legal point of view and liability point of view. And when I mentioned the human dimension before, it's not only about training and the knowledge of the operations, it's also about liability and who is liable for what. And everybody knows how sensitive it may be sometimes between a pilot and a controller, who is liable for a certain action, who is liable to avoid collision with terrain, depending on the phase of flight. And this is something that has also to be taken into account, because I read in some white papers here and there, the automated system will be responsible. But who is the automated system? Is it the software developer? Is it the owner of the system? Is it the operator of the system? So this is something that cannot be ignored either, and the rules are there for that purpose also. So just to name a few.
Thank you very much, Olivier. Very important topics you have put on the table. And I would like to build on one of the topics you have put on the table, traffic density. And the question for Jörn. Jörn, it is not, I will say, only specific for VOLOCOPTER, but it's all specific for all electric aircraft. That, the endurance will be what it is, what the batteries technology give us. And you have said one important thing. So you can only follow a very short, a direct trajectory, very predictable one, and there won't be possibility to manage unpredicted emergencies. So there will be one predicted emergency you will be able to manage, but unpredicted ones won't be able to be managed. And And you don't see that your operations are in need of a traffic controller. So we're not going to put a traffic controller on the Vertiport. So what are your views? I mean, are you already considering how you will manage the capacity of your initial operations? Because as Olivier was saying, I guess your business case is not one volocopter a day. So you will have more operations to make some business case there. So what are your thoughts about this? What sort of solutions you are thinking about how to manage the capacity and density in and out of Vertiport?
Right. Yeah, maybe just to come back to your first sentence saying, okay, we are not planned or not capable to accommodate unforeseen situation. I mean, of course, the operation will be safe, so we have to consider various cases. And I think, but just wanted to make clear there are some things that we need to consider in the planning of the operations, and this is different from helicopter operations. So I think when we plan for a certain route between a vertiport and another one, I think then we make sure that whatever happens, we are safely operating. So just to make that very clear. And the concept that also comes here into the game is what we call, or what is called the continuous safe flight and landing. That is clearly to be distinguished from emergency procedures. So emergency, everybody knows that. I mean, then you have to go immediately down. That's something you cannot really plan, and the pilot has to deal with that situation. But we even have that also coming from the VTOL certification requirements of the aircraft to make sure whatever happens, also in a degraded mode of the aircraft, we are safe to continue the flight. And if we cannot go back to the original vertiport or the planned destination vertiport, there is always a chance to land the aircraft safely in a pre-surveyed and planned alternate vertiport. And that is what we also discussed in the EASA Ops working group. So I think just to make that very clear, there is no safety issue when we operate the aircraft in the city. When it comes to capacity, yes, definitely. I think everybody is aiming for a higher skilled operations because it is a service, obviously, that should be affordable and available for everybody. So we don't intend only to operate a very few aircraft. And with that comes the challenge to bring in more aircrafts and make whatever it takes possible to have that safe operations. And with that, of course, as long as we have the pilot on board, according to visual flight rules, see and avoid applies, and this is actually given a certain limit how close the aircraft can fly. And that has to go hand in hand with the vertiport operation. So it's a very high complexity. I think something you can still do in your brain. Even the masterminds are not doing that. And with Excel, so you really need some models to simulate that. And that's what we're actually doing to find out what is the maximum capacity. And I think we have some good figures already to know what with the given setup, be it the capability of the aircraft, also the capacity of a vertiport, and there's of course we have to see how we move the aircraft on the ground between the FATO and the stand, so how quickly we can actually vacate FATOs, and all that comes into the equation when it comes to capacity. In the mid and long term, and we are working on that already, I think we need systems clearly to support that. That is what we call the VOLOIQ in VOLOCOPTER. So clearly a system that we can use both for strategic and tactical planning, and also for all the operational needs that we have with the battery, energy, monitoring, and so on and so forth. So with that systems, we also have the chance, of course, to bring some functions that we mainly maybe see in other stakeholders, be it ATC or in the aircraft, down to the ground. And I think that is a chance we actually have, that we can set up a system in a way that we put in the capabilities that we need in the places where we can do it. And I think also as an operator, we are in a position to actually provide services to ourselves and probably to others as well, in order to make that operation really efficient. And again, I would like to use that analogy with the cable car, in a very seamless way. And of course, if others have to be integrated, we are happy to have that interface and then see how it all works. So with that, I think there are chances to see what are the roles of the air operator traditionally, what is needed in terms of capacity managing. Is it some external party? Is it the air operator himself or as a company? And what also services we need in order to be aware of all the traffic that is going around us. And then, of course, the more separated the operations is, the more predictable it is, and I think the more the smoother it can be done, but at the same time, of course, if we have to integrate with other airspace users, then the complexity rises, and we need use-based services and systems as well here that help to managing the capacity. And we have that capacity and demand balancing. We have been discussing that in other projects. Also, just to mention, I mean, project like the Chorus XUM project, looking specifically into that, how we also can make sure is that what we need, a kind of slot management, is that reasonable time to react, and all these concepts that have been discussed already in traditional aviation. I think we can now good apply and see how we can adopt them also to the VTOL operations and urban air mobility. So there are some solutions coming up, all the discussions we have with EUROCONTROL and other partners here. And exactly, we have to do that also maybe in the further work when it comes to SESA, where we are founding members. So I think there are some topics we still have on our table, but I think we have some ideas and tools, and I mentioned that with our VOLOIQ, in order to also for initial operations and the next step already to increase the demand, and happy to discuss that any further and to see also with local partners. It's not only on us as VOLOCOPTER to decide how we do it, but also with the local authorities and the ATC organizations, what is the responsibility and how we can have agreements, who takes what, and what is the normal procedure and what is the off-normal procedure.
Thank you very much for this insight, Jörn. So very interesting, your VOLOIQ. So looking forward to see that. So Thomas, so we are now going to deliver the first MPA. How do you see the second MPA, the second proposal for OPSTER 2? So how do you see this work is gonna go on?
The work will go on as more or less as a continuation of what we did before. Me being the leader of that activity, I will have to reactivate the expert groups, and then we will have to go again and take a look at the assumptions we took. Do we need to adapt them? Are there any changes that require us to apply some different thoughts? And then we need to go and more or less one by one go through the whole of SERA and discuss how we may accommodate this, and if we need to adapt the SERA. And so far we only talked about the SERA here. Don't forget we have the ATM ANS rule behind as well, and we may have to consider if we need, and I'm sure we will have to do changes there. And yes, it will be a very challenging thing, where, as in this phase, we will have countless expert group meetings, and I'm already looking forward to have such experts in the groups. And I'm sure we will achieve something, but as I said in the one slide, we will depend on some other developments. Will there be technology available? Again, the DAA. Will there be some other ICAO framework available, which will be the basis for our work?
Thank you very much, Thomas. And so Uwe, you want us to do integration. What are your suggestions for us for the next phase of work?
Well, first go into practice with Type 3, for instance, and try to find out how it works, of course, and have a good look on the see and avoid principle with the pilot on board, if all the information Jörn just mentioned is sufficient for him. Because if I have the restriction, for instance, from energy type of view, and I have an emergency case or any conflicting situation, then the energy limits my capabilities, of course, and that's not a normal procedure, of course. In the manned aviation, we have the rule that every flight has to be planned with a reserve of 30 minutes. But if the electrical system, my VTOL, has only a capability of 27 minutes to fly at all, then there is no space available for the safety. And therefore, we have to change the way to operate. And there is a task of the USSP or the ATC to get knowledge of the situation, or the pilot must inform them. Better is automatic, as Jörn already mentioned, automatic transfer of the situation, and then to make a flexible modification, let's say, of the use-based environment. I cannot accept, for instance, as a UAS pilot, if there is a segregation in such a way in the USS, in the U-space airspace, that if there's coming a non-cooperative manned aircraft, that everybody has to go away and I cannot further make my normal business. And so we have to find solution also on that. On the other way, if I am flying as a manned pilot, I don't like to be segregated out of all that airspace because they are UAS operating. And so we have to do a lot of harmonization work on that, even if we don't have the standardization in identification and conspicuity.
Fair shared use of the aerospace, I think we need to. So thank you very much, Uwe, for this insight. So also a lot of, I would say, interesting thoughts and also interesting challenge. And before giving the floor to the Commission, I think I'm gonna ask for some questions because we are running a little bit out of time, although we have 1 hour and a half. So we have 3 questions in Slido. We can perhaps address one of those. And for those of you who are thinking on questions, just please also put your hands up if you have any question and you want to address them here in the room, just verbally. So could you elaborate some more on the role and responsibilities of USSP in U.S. in regard to the intelligently managed both UAS up and air taxi? Will there be a prioritization of UAS or use of segregated 4D trajectory for both air taxis and UAS? Nicolas, how do you see that?
So, as I alluded to earlier, today, and it's mainly because of the regulatory framework, U-space service providers can only provide services to unmanned aircraft. So if we are talking about air taxis without a pilot on board, then it's considered as a UAS, and it could be handled by the U-space service providers as any other UAS from a regulatory point of view. If you have a pilot on board, and if we are in controlled airspace, that would be type 2 operations. So it would take place, sorry, it would be type 3 operations. Sorry. And it would be conducted under the control of the ATC. That may change in the future, but that's the current situation. It's, again, mostly, I would say, for legal and regulatory reasons, not just the U-space framework, but you could actually go back to the ICAO convention. In terms of prioritization, I mean, there's currently no specific priority rules in U-space. We have priority rules in SERA. The priority rules in SERA are purely based on maneuverability considerations. So it's purely for safety reasons. It's not whether one flight has higher priority than another. It's purely for, I would say, collision avoidance and safety reasons. So we have to be careful when we look at priority rules in U-space or amongst UAS. Does the UAS need to necessarily give way to a manned aircraft? Is that the safest option? Of course, eVTOLs, they are supposed to be able to hover, stop in the air, which is not usually the case for fixed-wing aircraft. So there may be such considerations taken into account for priority rules as we develop them. To apply priority rules, you have also to identify what is the type of traffic. So again, the current priority rules are defined on the basis of visual identification of the other aircraft. This may not be applicable to U-space or an automated system. So this is something to be taken into account.
So we will need to build the priority rules within an automated system. So is there a profitable business case? Sorry, I can't hear because I am unable to read from there. With trained pilots flying eVTOLs under BFA? Yeah.
Well, it's a valid question. I'm not sure that is really related to ATM SERA, but yeah, if I can.
No, it's
not. Certainly there is. Otherwise, we wouldn't go
Do
this way. I think it's a very pragmatic way, and everybody knows mid and long-term goal is to reduce the presence of the pilot on board. So yes, I think for us there is a business case for that, obviously, but the clear aim is to go to high automation. And the service availability, I think, is not too low. Given the increasing number of flights, I think, yes, we will start with a smaller number. We will increase by that, but I think that's the available that we have. And that's not only the pilot, but it's also the airspace as such and the availability of vertiports and the capacity. So I think there are a number of factors that will determine the availability, service availability. And I think with that, if you can just allow me just one more point to the previous question, what you said, Nicolas. I mean, what I also read and what is written in the NPA, as you will see that, is maybe when you design, I mean, the ones who are involved in the design of U-space, airspace, is it rather the exception or the rule that manned aircraft will fly into the U-space? I think that is a bit of a mindset we have to challenge a bit. If that, I mean, the clear intention is, and we know the regulatory framework and the legal implications, that U-space airspace providers, U-space service providers can only provide services to unmanned aircraft. However, if we fly with a manned aircraft, the VTOL, which is considered to be a UAS, it's a contradiction itself, I know, but want to fly in airspace that is declared as U-space airspace, it has to be activated and deactivated. And we discussed it quite intensively, how could it practically work? And then it was, yes, it is a smart airspace design that is required here to enable that, and maybe it's rather the exemption that the manned aircraft will fly into airspace, U-space airspace. I would challenge that, or to see specifically now in the city centers, as you know, in talks with European cities here, and if there's U-space established, U-space airspace, and for drones, and we want to fly in and out, so that which actually put some kind of challenges to activate and deactivate quite frequently. So we are more than happy to discuss the implications on that, and everybody should keep in mind that both, and coming back to what Uwe said, manned and unmanned aircraft may use that airspace, so we should design it in a way that already allows both kinds of aircraft to operate. And I would also support what you said, Nicolas, that we can make use of U-space services to the extent possible in order to allow both aircraft to use the same airspace. And we know we have to go step by step. But what is the assumption? Is it more for unmanned aircraft, for small drones, or is it also designed, or mainly designed maybe for manned aircraft in the beginning already?
Aerospace design. So, Olivier, how do you see that U-space, aerospace, and the establishment of that aerospace, how that could help
Well,
the aerospace users?
based on everything we said before, for the time being, the reason dictates that such kind of airspace should be kept at very low level, where we expect that less traffic will be encountered and safety easier to preserve. And at least from a pragmatic point of view, a step-by-step approach indicates that it would be safer to wait for the first result of the new operations before we move further and before we move higher in the airspace, especially considering what I said before, the common altitude reference system, the necessity of conspicuity, the detect and avoid capabilities, all that becomes much more complicated when you go higher in altitude. So in the beginning, that's really, I believe, something essential for the state regulators when they consider establishing U-space airspace to look at it from a safe and pragmatic point of view and start with a low level, if not very low level. And I believe there should be some kind of natural organization of things there, because the business case of a certain number of UAS operations, like urban mobility, for example, is more on urban areas than in the countryside. And normally on urban areas, apart from police and emergency helicopters, that's not the area where you expect to find balloons or general aviation flights. So it's also something to be considered by regulators, how to possibly give a certain priority to certain types of activities depending on the place where they are expected to happen.
Thank you very much, Olivier. I think that's really, that was the intent of the regulation, to start at the beginning in the very low-level aerospace, and to, as soon as we get experience and we can get feedback on how these operations will work together with the manned VTOL, then we will go further, and we will, with the help of more advanced services that they are demonstrated in the umbrella of SESAR project. So, very interesting question is on the chat, also related to disappear. no, wait. The separation. Thomas, you are a surveillance expert. So today we don't have any separation minima in the EU space aerospace, neither we have set any separation minima between manned and unmanned aircraft. What is it that we need to establish as a separation minima?
Okay, I think we all agreed and understood then that in the initial phase, there is no such separation between manned aircraft and UAS as we know it within manned aircraft. And in order to enable such separation, we need to establish a framework, and my main background is surveillance, to ensure that there is an air picture illustrating all the traffic which is flying around there, including manned and unmanned aircraft, in order to enable whoever that will be at the end then, the ANSP, the USSP, or both together, to ensure the separation. And if you would ask me today about values, numbers, I could not tell you. This will have to develop because I see a big difference or a very big challenge. Let me start it like this. As said, I'm from the manned aviation surveillance background. I immediately think about detection. How do you want to detect with common systems like a primary radar, a little drone of 1 kilo or whatever size? How, if you detect it, do you want to ensure what today a tracker is doing, predict where the aircraft will be in the next second? Because such aircraft, we know in 1 second they fly forward and in the next second they fly backward. So this is, for me, a huge technological challenge, which then has to be combined at the end with operational aspects, like how many meters do I keep them apart? So I think there is still a long way to go. To stress it again, today it's not yet a problem because we will simply keep them apart. When a manned aircraft enters the U-space, be it in controlled airspace or uncontrolled airspace, in the controlled, the ANSP will simply tell the USSP a manned aircraft is coming, and then the USSP has to move aside the drone. And if it's in the uncontrolled airspace, the USSP receives the signal of UVIS conspicuity device, and he has to do the same thing, move the UAS aside. So I still see a long way to have something from the technological and the operational side available, which will enable us to do it as today. But what will have to develop as well is this automated functionality. Maybe in the future things are able to talk to each other and say, I'm coming, you move aside. We will see.
And that's good. So I would like, there are 2 more questions on the slide, but if someone of you have, okay, so we have let's try to address also the people here, and we go back to the colleagues virtually. So, Angas, when you made the question, please, if you could, we have no mic. Where is it, the mic?
On the stand.
You need to go to the stand. Please go to the stand and say your name, organization to the question.
Yes, thank you very much, Maria, and to the panel for an enlightening discussion. My name is Ansgar Sickert. I'm representing ACI Europe. It's the Association of Airports. And from that angle, I have a specific question. And we've seen that the complexity of integrating manned, unmanned aircraft into different airspaces is complex enough. But let me just add one additional element. Now, as ACI, we've just published a position paper on UAM because for airports, it's become absolutely clear that we will have potential business with urban air mobility, with air taxis serving airports. There's a lot of interest from the airport side, but also from eVTOL manufacturers to look at airports as potential destination and origin traffic points. So we've heard about the challenges, but now if you look at the business model for air taxis in particular, they need to, their business model is basically dependent on quick access to whichever destination they want to reach. So the service has to be fast, and the access to the airport or from the airport has to be fast. So that means basically having vertiports very, very closely located to the terminal buildings. Otherwise, the business model doesn't work. Being close to the terminal building means you're also very close to the runway system. For the business model to make sense for the airport to accommodate eVTOLs, that means you have to have completely separate operations of your regular aircraft movements and of the air taxis. So how can you, or does the regulation envisage to bring that together, that you can have your regular safe airport operations and facilitate separate access to eVTOL, to vertiports, eVTOL operations to the airport at the same time in a safe manner?
Thank you very much for the question, and we'll go even further. You can have the vertiport in the air side of the aerodrome.
If I can just respond to that, it's true, you can have that, and I'm sure there'll be operational cases, but it seems to be consensus amongst most of the airports that it's more attractive to have it on the land side because it facilitates the operation. So this seems to be the consensus amongst the airport industry, that land side would be the more likely scenario for a lot of the cases, not all of them. No.
Thank you very much. I would address the question to this side of the room.
Yeah, sure. Thank you for the question. Very, very, very interesting question. And I agree immediately that the land side makes more sense than the air side, given the speeds and the pace and type of traffic. I would not be so worried about that, because any air traffic controller knows that accommodating helicopter traffic with a runway being used for IFR traffic is not such a big deal. Having it with a high density and regular delivery of machines in an hour would also be possible if it is well thought in advance and if the procedures are properly designed. Every airfield and many cases exist where you have one or several IFR runways, and on the side you may have VFR operations. You may have within the CTR sometimes a little flying club not so far away from the IFR runway. If the procedures are well known by all pilots and well designed from the beginning, I guess it's perfectly compatible having urban mobility traffic coming from the sides of approaching runway. Now, if you have a triangle type of setup with 3 runways and you want to use 2 runways which are not parallel in the same time, that could become a little bit more tricky. But in the general case with 1 or 2 parallel runways or only 1 runway, I expect this should not be a too difficult problem.
Do you agree, Jörn?
Yes, I mean, we are already looking into these cases in a number of cities already, and I think that is a similar challenge. I would agree to what Oliver said. It's possible. I think if you assume that the aircraft would land at the same runway where you have a high frequency traffic, I think that doesn't make sense really, because it will limit the capacity of the airport, and it will not be predictable really, because ATC had to interfere and give instructions, and this is, I think, not the way we want to operate. So I think the more we can separate that to some extent, not sure if you need to change or look into ATM SERA in that respect to change something, but as I think as you just described it, I think there are ways, but it really it's very specific to the individual site. How we manage that, but definitely I think that's the way to scale up the operations and to make that happen, and I think it's possible, yeah.
Thank you. So we have time for, well, we don't have time, we are already over, but let's just take one question, okay, 2 questions, let's see, short.
Good morning. So Nicolas Marcoux from French DGAC. It's actually the question in the Slido.
Okay.
It's about the segregation. We always talk about segregation as a safe way to address separation between UAS and manned aircraft. But in practice, segregation only works if manned aircraft knows about the segregated airspace. It's not a magical wall in the air. And we know that in preparation of flight, in general aviation or for emergency operations, there is a high number of NOTAMs. When you read the NOTAMs, you find WGS 84 points that you have to put on a map. So how can we improve actual segregation without conspicuity? Do we need additional tools for manned aircraft crew to help prepare the flight? Because the more operations we'll have for US, the more segregated airspace we will have. Thank you.
Another very good question. So, Nicolas, do we have something in the drones strategy on this?
No.
No, okay.
Over to you. No, I think it's a very valid question. No, I'm not a general aviation pilot, so I think I will look on my right.
Yes, we
to
go
complement
straight now
the-
to Uwe because
the
he's
answer.
very calm there, and so we're gonna go back to him.
Shall I take over? Okay.
Please.
Yes.
Fine, yeah. Yes, I fully agree. There's a lot of number of NOTAMs to be viewed and separated and read, and that's not very practical to take such a message in a NOTAM. But as I remember, we have planned up to now, if there is such a kind of segregation, if there is coming an unknown manned traffic, let's say, which is not cooperative, then the USP has to separate by putting the US aside. And by this, I don't need no preparation. And in emergency cases, no NOTAMs make sense if I have to go down to land in a special site, which I select due to the situation. I cannot take care of NOTAM or other regulation. I have to go down where I am. And so any other situation has to be managed by the USSP in that case. The US must go aside, and that's the only practical way at the moment. In UAV-DACH, we have had a very smart solution in 2014 already, where we proposed to use a system based on mobile telephone or whatever. We called it the SIM card for the US pilot, to make a ball, or like a ball around every US, and the US communicate each other, and if the balls are conflicting, coming to each other, they automatically separate. That would be exactly a system which would work with no interaction with the USSP, because then we have a delay which is not feasible in a high density environment. So we have to wait for the future when we have systems like this with automation, where the aircraft themselves make the separation.
And a good logic of separation.
Of course. Yeah.
Because otherwise it creates a chaos. The separation may create a chaos on the other way.
Maybe just a remark. In fact, we progressed in that direction with drones, with the publication in electronic format of the US geographical zones,
Yes.
with the geo-awareness service in new space, and I think that is maybe, those are maybe building blocks that will eventually also support the general aviation community.
Yeah. I think there are good points what you built, and we need to think about that also in the very short future. No future, tomorrow actually. If not today, after the conference. Last question, and we need to conclude because we could talk here for the whole day and weeks, but yes, please.
Hello, my name is George Zagopoulos. I work for AV and unmanned aircraft manufacturer here in the Netherlands. We deal in small-ish aircraft in the specific category, and I wonder how these Type 3 operations that you said that we are about to roll out of manned eVTOL, how will they help us? What can they teach us? How are they useful for understanding and planning unmanned operations of Type 2? Because they are manned, so we're not talking about unmanned aircraft, and they are of much higher risk, if I make myself clear. mostly towards the EASA representatives?
Hola. Thomas? Well, you are in the specific category. So, but when we are talking about Ops Type 2 in our concept paper, and this will be also explained by Irina later on in the technical workshops Ops, we are talking about UIS in the certified category. So when we are in the certified category, means we need to be certified for high-risk operations. So most likely you will be operating transporting passengers.
No.
No, because you are in the specific category, but the Ops Type 2, I mean, it's like what Jörn was saying. We have, what is your picture? So my picture, or the picture that we have for Ops Type 2, is really the high-risk operations. It's you are carrying passengers, dangerous goods, or the impact of the collision of that aircraft with someone. And,
or at some point, much bigger aircraft.
Or much bigger aircraft, that the impact on the ground or high density
over
or
urban
congested
environments,
areas.
right, yes.
Yeah.
So my question still stands, how can a pilot program of type 3 with manned aviation help us to understand unmanned aviation better over an urban environment?
That is the concept. That is why at the beginning, so it's going to be a stepwise approach. I think you can explain as well. So it's a stepwise approach. So we're going to try to learn how we roll out these operations, so what sort of corridors, trajectories, the use cases, and how far you can take the pilot out, automate certain functions, and then how we can go further with Ops Type 2. We learn a lot in this exercise, by the way. There are at the moment no operations, but still by discussing and with the SERA projects and demonstrations and try to just do things, how things are being learned. So we will take all this experience for that work. I don't know if the panelists will...
I believe also the management of traffic density in urban environment, the regular use in commercial environment of electrically powered machines, the step-by-step understanding of the evolving role of the pilot. As Maria said, the pilot in the beginning will conduct a number of tasks, including primarily see and avoid, that will stand longer, but at a certain stage you may discover that for navigation, for a number of other functions than see and avoid, you have validated the possibility to operate in high-density urban environment with a pilot that becomes necessary only for the see and avoid, and that will reduce the scope of what needs to be addressed for the Type 2. So that's where we believe the first phase experience and return would be useful and beneficial.
Very well. Thank you for answering my question.
Thank you very much. So you have seen we are at the starting point of this in terms of regulatory developments. I mean, concepts are there, but you will see the first proposal for what we've been discussing. Don't forget to read the safety assessment. It's very important. That we have, like Jörn said, we are all in the same picture. So your concept that when you assess the MPA, it's no different than the concept that we were having in mind when we worked on that proposal. Review it, come back to us, and we hope you enjoy this panel. As I did, I would like to ask you to please give a big applause to the panelists. And I would like just to ask you 1 minute, because I would like to ask you for a big applause for a colleague of mine who passed away, but he was one of the team. So big applause for Emmanuel Radev. Thank you.